அனைவருக்கும் வணக்கம். I am Dr. R. Shivakumar, Assistant Professor in the Department of Chemistry, AJ College of Arts and Science, Pudukkottai. Now I am going to discuss the basic concept, the atomic structure, which includes the quantum theory. The quantum theory was proposed by the Max Planck and later extended by the Einstein. The quantum theory states that the hot vibrating body does not emit or absorb the energy continuously, but it does it discontinuously in the form of small energy packets or bundles known as the quanta or photon. In the case of light energy, the energy of radiations, that is E, is directly proportional to the frequency of radiations mu, that is E directly proportional to mu. The energy is given by E is equal to h mu, that is hc by lambda, where h is the Planck constant and the value is 6.6253 in 10 power 34 kilogram meter square or second inverse. The absorption or emission of energy in the form of integral multiples of quanta is known as the quantization of energy, that is E is equal to n h mu. A hollow sphere is coated inside with a platinum black and having a small hole in its wall acts as a black body. It is a perfect absorber or a perfect emitter of radiation energy. At a particular given temperature, the intensity of the radiation increases with the wavelength, approaches the maximum and then starts decreasing. And it also explains only the black body radiation. So Einstein extended the quantum theory to all types of electromagnetic radiations. Another topic is the photoelectric effect. The photoelectric effect was introduced by the Leonard and explained by the Einstein. It is the emission of electrons from a metal surface on exposing it to the radiation of a suitable frequency. It is readily shown by the alkali metals like potassium, calcium, which have the low value of ionization energy. So it is readily emit the electrons when passing the radiations. When a photon strikes on the metal surface, its energy is absorbed by the metal and consequently emission of electrons takes place. A part of energy of photon is used to overcome the attractive forces and the remaining energy is used to increase the kinetic energy of electron, that is kinetic energy of m is equal to E minus phi, where E is the energy of radiations and phi is the work function. So the kinetic energy is equal to h mu naught, that is here hc 1 by lambda minus 1 by lambda 0, where mu 0 is a threshold frequency energy, that is a minimum energy frequency of light radiations need for the electron emission. If the frequency mu is greater than mu 0, kinetic energy is positive, therefore the electrons are emitted. If mu is greater than or equal to mu 0, that is a kinetic energy is 0, therefore no electron is emitted. If mu is less than mu 0, the kinetic energy is negative and there is no emission of electron. Simply we can say the photoelectric effect directly proportional to the frequency of light radiation. The kinetic energy of electrons does not depend upon the intensity of the light. However, the number of ejected electrons depends on the intensity of the light. Now, another topic is the de Broglie equations. It explains the dual nature of the electrons, that is called as dual nature theory. The de Broglie introduced a dual nature of a matter, that is for subatomic particles, that is electron, proton and neutrons. According to the de Broglie theory, a matter has both particle as well as a wave nature. A wave nature of electron is confirmed by the Davis and Germer by the diffraction pattern experiment on the nickel surface. The patterns obtained were found to be the same those predicted by the Bragg equations for the X-rays. That is E is equal to mc squared for the particle. We can say that E is equal to h mu, where mu values is 1 by lambda. So E is equal to hc by lambda for the wave nature. From the equation 1 and 2, we can rearrange hc by lambda, that is mc squared, and Then rearrange 1 by lambda is equal to mc squared by hc, and lambda is equal to h by mc. If c is equal to mu, that is lambda is equal to h by me, finally we can say lambda is equal to h by p. If a particle has more mass or momentum, it has less wave nature. That is, the wave nature for the subatomic particles, electron is greater than the proton, proton is greater than the neutron. Heavy object have less wavelength due to the more mass relation between the wavelength and the kinetic theory. So we can say the lambda is equal to h by square root 2m. Kinetic energy of m is squared is equal to electron volt. So we can rearrange this equation of m is squared is equal to electron volt, v squared to e v by m. This equation can be used only when microscopic objects are taken and the energy is expressed in terms of the speed only. So another important topic is the Heisenberg uncertainty principle. It is only applicable for the subatomic particles. Heisenberg uncertainty principle states that it is impossible to measure simultaneously and accurately both the change in the position and the change in the momentum of subatomic particles. If the value of one is determined with certainty, the accuracy in determining the other value is compromised. So it is also called the principle of indeterminacy. Mathematically, we can say that del x into del p is greater than or equal to h by 4 phi. Del x is equal to uncertainty in the position and del v is equal to uncertainty in the velocity. So we can rearrange this equation del x and del v is greater than or equal to h by 4 pi m. Del E is the change in energy and del T is the change in the time at a particular time. The change in position is 0, the change in momentum will be the infinite and vice versa. It applies when both del x and del p are along the same axis. So another concept is the concept of the probability. According to the Heisenberg uncertainty principle, the del x and the del p of an electron cannot be found accurately at a particular time. So this leads to the concept of the probability. According to the probability, which it is possible to predict the probability of locating an electron and specific energy in a given region of space around the nucleus at a given time. This leads to the concept of the orbitals. So okay, thank you.